Hello class, welcome to Geometry Lesson 8.5, which is all about problem solving with trigonometry. By the end of this lesson, you should be able to use trigonometry to solve problems. So there are just a couple of new things that you are going to learn in this section, otherwise it's kind of combining everything from this whole chapter together in one place. So one of the new things that you're going to learn is how to identify angles of elevation and angles of depression. So if we look, the book gives us a nice picture that describes an angle of depression. So an angle of depression is formed by a horizontal line and the line of sight to an object below the horizontal line. So let's say you are standing and you look down at something. It's like there's an invisible line between like your eyes and whatever object you're looking at. Those lines, your line of sight is always going to be represented by a solid line. And then often those horizontal lines that are talked about is kind of an invisible line that would be like if you're standing looking at something, it's almost like there's an invisible horizontal line going straight out from your eyes that's parallel to whatever you're standing on. Okay? So your eyes would be right here and they're looking down. And then this would be if you were looking parallel to the ground. Okay, so you see how it would end up forming a nice right triangle to do some problems with. So angle of depression is when you would be looking down at something. Okay, so that means that the invisible horizontal line is above what you're looking at. The angle of elevation is, let's say you're standing and you're looking up at something. That angle, so here, angle 4 would be an angle of elevation. Again, you have the invisible line. Usually for angle of elevation, it's the ground. Whatever you're kind of like standing on is a way to think of it. So angle of depression, looking down. Angle of elevation, looking up. Okay. So the directions say identify angle 2 as an angle of elevation or an angle of depression. Do the same for angle 3 and explain your reasoning. So first, let's look at angle 2. Angle 2 is formed by this. So you can see we have our nice horizontal line below us, and we have a line going up from angle 2. So that would be an angle of elevation. Angle 3, did not mean to do that. Angle 3, we have the horizontal line above us, and then our angle opens down, or looking down, so that would be an angle of depression, okay? Now, let's do a problem using angles of elevation and depression. So for a reverse bungee ride, Regan stands halfway between two vertical posts, and two bungee cords extend from the top of the posts to Regan's waist at a height of 1 meter above the ground. How tall are the vertical posts? Okay, so we see a little bit of information. We know that between the two posts there is 8 meters, and Regan would be halfway between those two posts. So if I were to draw a simplified triangle, it would look something like this. I know that I'm trying to figure out how tall is that post. And then if Regan's halfway, that would be 4 meters. I know that this is 70, and I want to solve for this measure here. The way I would do that is I have the angle 70, and I have my adjacent, and I want my opposite, so I'm going to use tangent of 70 equals my opposite over my adjacent. So to get x by itself, I just have to multiply 4 to the other side of the equation. And if I plug that into my calculator, I end up with like 10.989. So I'm just going to say x is about 11 meters. But I'm not quite done, because if I look at this picture, remember, or even the information, we know that the triangle, is kind of elevated 1 meter above. So if this is 11, we have to still add this bottom portion there. We have to add that 1, so I know that the post is about 12 meters tall. Okay, why don't you go ahead and see if you can solve this problem. Good luck. All right, for this problem, you actually had a couple of different ways that you could solve it. We were given this angle of depression is 23 degrees, and we were trying to figure out how far the bus was from the tower. So if we were trying to figure out how far the bus was from the tower, we would need to figure out this distance. And there's a couple different angles that we could use. The one cool thing about angle of depressions, or angle of elevation for that matter, is alternate interior angles would be congruent. So if I were to draw another tower here and complete it, do you see how we have a rectangle, right? Because we'd have all 90-degree angles. So what I could do is say, hey, these two are alternate interior. That means that they are congruent. Or you could say, well, I know that this has to form a 90-degree angle here. So you could say 90 minus 23 is 67 in order to get the angle that's inside the triangle that we're working with. It's really important that you don't use the angle that's outside, because if you used that 23 and you said, okay, this is my opposite and this is my adjacent, that's not true. This 180 is not even touching that 23 degrees. So it's really important to make sure you use angles that are inside. On the left here, you can see the work that you would use to find your answer. So hopefully you ended up at about 424 feet. All right, example 3. This one is going to have a few steps, so hang in there, okay? We know an instructor holds a safety rope at point C for a student to rappel from, sorry, that's a typo, it should say from the anchor point T. The rope between them currently measures 61 feet. How much more rope should the instructor let out so the student can make it to a resting point at point R? All right, so we have a couple of different triangles happening here. We have CHR, which is kind of the smallest one there. We have a right angle, and we know that this is 79 degrees, and then we have R up there. That's all we know for that one. And then we also have CTR. That looks something like this, which is not a right triangle. I'm going to try to draw that maybe a little bit better. So then we have CTR, and we know that it's 75 degrees from there up to this measure there. So I can figure out what this angle measure is by saying, okay, if this whole thing was 79, and then this is, oops, that should be a 5. And then this is 75, I would do 79 minus 75 would give me 4 degrees left for that really small sliver right there. Okay? So 79 minus 75 gave me that small sliver. Then I'm trying to find, this is also X. So if I'm trying to solve this, I'm trying to figure out the resting point R. And in order to figure that out, I know that my repeller is at T, and they need to get down to R. So I need to know what that distance is between those 2 points. So what I'm going to do is, since TR isn't on a right triangle, I'm going to have to use law of sines. And I would say sine of X over, it would be 61, because the side opposite of X is 61. And then equals sine of Y over TR. Now, our Y value is actually something that we already solved for. So I'm going to replace that Y with 4. Okay. And then I just need to figure out what my X value is. If I look at my X value, I see it's part of a straight line. So that means it's supplementary to whatever angle is right there. And I can figure out what that angle is by saying 180 minus 90 minus 75. So I can figure out what x is by saying there's 180, sorry, that's not x. I can solve for, I'm going to call this just m right now, that last angle in that CHR by saying 180 minus 75 minus 90. That tells me that I have a 15-degree angle right there. And then x is supplementary with that angle, so I would say 180 degrees for supplementary minus the 15 degrees that was already taken, because here would be x. So 180 minus 15, x equals 165. So I'm going to replace that x with 165. And now I can solve this problem. I can say, I can use my law of sines. And I can say 61 times sine of 4 equals TR times sine of 165. Divide both sides by 165. I would have 61 sine of, I'm going to write it like you would type it into your calculator. Your calculator automatically puts that first parentheses, so I encourage you to close that. And then I also encourage you to get in the habit of putting parentheses around everything in your numerator. So when you type it into your calculator, I want you to do an open parentheses, 61 sine 4, close your sine parentheses, then close your numerator parentheses, then hit divided, and then sine 165, close your parentheses, and you should end up at about 16 feet for that distance. Okay, so I know that problem was a little complex, and I maybe didn't explain it in the best way, and I'm sorry for that. So if you still have a question on it, please be sure to reach out for some help. I'll try to quickly recap it for you. We were trying to solve for TR, which was on a non-right triangle, so I knew I had to use either law of sines or law of cosines. And when I set it up, I had sine of sine of x, which we didn't know what that was. We solved for x, though, by figuring out what it was supplementary to. Over 61 equals sine of y, and we figured that out by doing the whole angle minus the smaller angle to get the last little sliver there, which was y, and that was 4. And then we just did law of sines. Okay. Now, the very last thing for you guys to learn in this lesson, this one kind of new, is how to find the area of a triangle when you have two sides and an included angle, so side angle, side situation. Okay, so the way that you do that is, first, if I had A, B, C, what I would do is I would draw in the height, the altitude, and that would be H, okay? And the area of a triangle, as you guys know, is 1/2 base times height. And then if I look at this, I would have 1/2 base, but my height, the way I would solve for that height would be if I took that smaller side, it would be, I would take this angle, so A, and I would say sine of A equals my opposite side over my hypotenuse. So that's how they came up with that part. And then to get H by itself, I would simply multiply C over. So it'd be C sine of A. Okay, so C sine of A would be H solved by itself, which then I can plug in for H. So I know that in order to solve this, I'd have 1/2 BC sine of A. So you can use this with any of the angles. So that's it written out with angle A. Here's it written out with angle B, and here's it written out with angle C, okay? So basically the formula, 1/2 times the two sides times sine of the included angle, okay? So you need to learn that. And let's look at what that would look like with numbers. So here I have triangle FEG, and I would do 1/2 times, since I have angle E, I would do G times F times sine of angle E. So it'd be 1/2 times 3 times 4, because F is 3 and G is 4. So actually, 3, 4. So what you would do, you do 1/2 times our two sides times sine of our angle, plug that in, and you end up at 5.4. All right, why don't you go ahead and try one on your own? Good luck. All right, hopefully for this problem, you set it up 1/2 times 9 times 15 times sine of 51. And if you multiplied all of those together, that was 67.5 sine of 51. Plug that into your calculator and you get 52.5 units squared. If you have questions about that, please be sure to reach out for some help. And our last slide is just a quick refresher on the new things that you learned in this lesson. So you learned what angles of elevation and angles of depression were, and you also learned how to find the area on a non-right triangle. So if you have any questions at all, please be sure to reach out for some help, and I'm more than happy to assist you. Have a great day.